Can you hear me? You guys can. Okay. So my name is Mandy Botsko-Wilson. I'm a consulting architect with VMware, and I work in customer success. But today I'm going to talk to you about automating benchmarks for cloud infrastructures with VMware Weathervane, and then I'll show you how that can be blueprinted with vRealize automation. The standard disclaimer does apply, although in this case, everything I'll be showing you is already released. So, as you go into the cloud native world, there's a lot of questions about cloud infrastructure and how should I architect my application? What storage should I use? Should this service be on Docker? Would it be better to have this somewhere else? There's a lot of questions. There's a lot of flexibility, and it can be helpful to use some infrastructure benchmarks for your application to determine whether you should use a service on VMC on AWS native. Should you do bare metal, right? And as you move forward, how do you make those decisions? Private cloud, public cloud, etc. Well, we have a solution that has been developed in an open source called Weathervane that provides application-level cloud infrastructure performance benchmarking. So this can help you determine those solutions without having to try out all the different things, in your infrastructure. So what exactly is Weathervane? It contains a model application so that you don't have to use your production application and re-architect it in different ways. It's been modeled. In this case, the first model that's available as part of the open source code is the auction application. It's a modern web application that's very typical. We're going to look at that infrastructure in a minute to see what the architecture looks like on that. It contains a workload driver. The benefit of using a model application like auction is that you can build in the workload driver and the quality of service based on the actions that the users are going to take that are common to that application, and you don't have to build the point and click or all the scripting for your enterprise application that you're trying to test out. And then of course it has the run harness. That's what actually automates all those processes and executes the runs and collects the results. So it's really a three-part aspect there. So this model application, you should see that this looks very familiar, right? You've got your users on one end, you've got some load balancers, n number of web servers, some app servers behind them, a relational database, perhaps a NoSQL database there as well, some messaging. So when you get into the Weathervane deployment, right, that architecture should have looked familiar. Well, that means you can now deploy Weathervane in a flexible configuration based on what the application you're modeling looks like. You don't have to use all the services. You can see in blue the required services. Excuse me, you have to have a workload driver, of course. Those are your users. You do need the messaging server on there. You need an application server and the relational database and the NoSQL database on the back end. Those are the bare minimum services that you can deploy, but you can also distribute it as far out as you want. So you can model your enterprise application without having to architect that in a number of configurations. Underneath it all is, of course, the run harness. Once you have the Weathervane application running one of its tests, the auction application is available and you can actually log into it. You go to the IP of the web server and you can play with that particular web application and see what it looks like. So I put that up there for you. In fact, I have a little bit of a demo and you can see what you can do when it's actually running. This application doesn't run unless you're actually running a test. So as you run Weathervane and it's running the run harness, it brings this up and then you can see what it looks like individually if you want. Although normally, you probably wouldn't do that. But if you want to take a look at it, it is actually there. I had set this up in the next demo that you'll see, and I have it up and running. There are logons available. You can log in with the guest account, And then you can see what it looks like. You know, the user interface is pretty basic, but that's not really the point of this, right? You can see it does all the normal things in a auction type application. So that allows you to have both transactional records as well as the non-transactional database records as it works through this. And then the quality of service would be based on the various users, you know, the amount of time it takes to log in or perform various actions as part of that. Those are ultimately configurable so that you can, again, model your actual application more closely based on the time that you would expect things to take in your own environment. So as a performance benchmark, Weathervane hits most of the marks. It does have the model application. It's representative of a very common type of application. Because Weathervane is open source, it's on GitHub, and we'll get to that in a little bit. You know, it will continue to grow to develop more model applications that you can then benchmark against in your own environments. It has the workload. Those are the specific operations that model the users as you go through it. So it meets that criteria. It does do application level performance metrics. So it will compare the application performance across multiple runs. So you can, of course, run it just multiple times with the same configuration to find averages and see, you know, based on that. But you can also then tweak configurations. So, you know, what happens if I have the, you could do it from the perspective of having the application and the web server combined. We're going to see what it looks like if I Dockerize this portion, but I don't Dockerize that portion. Does that affect it? What if I distribute that load over, you know, some things are in the public cloud and some things are in the private cloud, like I keep the database perhaps in-house. And does that affect the performance? And you can find that out using the model application, again, before you try it on your own. Quality of service, you set what you expect it to do, which then it will report whether it has passed or failed that quality of service based on the number of users as they load up. Finally, what it is not is an industry standard benchmark. Because it's highly flexible and you can configure all of these options, that makes it not an industry standard benchmark. Because if you run it, you know, if you run it, it's going to end up in one configuration. If it's run over here in a different environment with different configurations, you can't compare those results. Now, you can do things to put the logic over top with the strict rules so it would become an industry standard benchmark, but that's not its intent. So this is the example of some various runs that were done based on a non-Dockerized versus a couple of Dockerized options for that auction application. What this shows you is how, you know, sometimes the performance may not be what you ultimately expect. They all perform almost identically up to about 12,000 users, at which point there are some challenges with the bridge network option in Docker, which causes it after that point to have severe latency and fail the quality of service there. The others basically perform pretty close up to about the 18,000 mark. You can, of course, determine how many users you want to load in. The more users will determine how much data gets loaded in the front end so that it can run those. The really key features with Weathervane is that it is a simple setup and deployment. I'll show you that. And you can deploy it very quickly. I think, you know, it probably, even if you were unsure of any part of it, I think you could get it deployed in a day without, you know, even if you stumbled around and tried 20 times. But in reality, it probably takes you about 2-3 hours to get it deployed maximum. That includes setting up a CentOS 7 VM from scratch. It has support for Docker containers. There is intention as it grows, again, it's open source, it's also continuing to grow, to have some other containerized options. It does do the variable loads, as we talked about. I didn't mention that it will have elasticity as well. There is elasticity service in there, so that as users, if you configure it to do so, as the user load grows, you can have it automatically grow out certain tiers of the application as well to support that. And you can test those options as well. So, as I was talking about, the installation requirements. So, CentOS 7 VM, just set one up, real basic, 2 CPU, 8 gigs of RAM. It does need, so the manual says about a 20 gigabyte hard drive. You can do it in about 16. but it does need the space for the tarball and the data, and as it expands, it does need a little bit bigger drive to start. You need to have internet connectivity, Perl, it uses Perl scripts, and the tools you need, of course, SSH to get in there. You can get the Weathervane tarball off the Git repository. You unpack it in root, or you clone it into root, and then you're going to launch that Perl script that's there. And then it installs. So as long as you have all your prerequisites on your CentOS VM, you know, you've updated it, it's all ready to go, it's very, very simple. In fact, I'll show you kind of what that looks like. You run the script, just autosetup.pl, it's in root, takes about 30 minutes to do the full installation. It loads, it uses Zookeeper, Tomcat, some standard services there, and then you're done. In this case, I'm enabling the DNS server as well then. It has an inherent DNS server. I'm enabling it on this particular initial installation because once you've installed it, the first thing you should do, run a test run. See what it looks like. Use all the defaults and just go run. And if you have to enable the DNS server to do that because DNS is where all those different services are. So let's take a look at that. The initial run. All I did was install, and then you run the initial run. I added the num drivers one. It's not actually overriding anything. You can optionally override any of the base configurations in command line. In this case, the default is 1 anyway for the workload drivers, but you can have multiple workload drivers against it. I let it elapse for about 14 minutes. And then at that point, it had reached the steady state. It had loaded all the data, started up all the services, and that's when I played with that auction application, and we saw the previous demo. And then it takes about another 30 minutes, because by default, it runs 28 minutes in steady state so that it can get all the tests that it needs. That is configurable, how long you want the steady state to run, and of course, how many users you want to spin up. So it loads, if you have a distributed load, it will start them up across the distributed model. In this case, it's all starting them one and done, so they're all in the same place. You can also configure the, oh, we can't do that. You could see it had the different configuration manager. It's got one web server, one database server. You can configure how many web servers you expect to have, as well as those other services, so whether they're collapsed or not. Once it's done, it does report right there on the screen whether the quality of service failed for any particular measures that you had. In this case, it does fail on 3 measures. That's all reported in a CSV file as well. I believe it's called Weathervane results.csv. You'll find that generally things are named in a very easy way, and you can export those off there and then look at them any way you want. It will continue to add runs. If you do multiple runs in the same run harness, it will continue to store those. Now, what's interesting is, I'm going to show you very quickly a run with Docker. So I take the exact same thing, it's all in one, and then it's going to run it with Docker. And what I'll show you is what the configuration file looks like. It has a lot of options, weathervane.config, again, like I said, there's no secret names here. And it's got a ton of options that are available to you. You can see all the details, all the defaults that are there, as well as details about each one. You know, it's well documented there. There's also documentation that's quite extensive that's available on the GitHub about how to install it and how to run it and what everything means. And then you can simply remove the comment there and you change it. So here, instead of use Docker, which by default is false, I'm going to say let's go ahead and use Docker for this. I also have to change, in this case, the networking from bridge to host, because in the environment that I was using, the bridge network, it couldn't even complete a run. So in this case, I have to change that for this particular environment. You can also, as you see there, modify what your Docker registry is. So if you have this in-house as opposed to exposed to the internet, you can do that as well. I just scroll right through there so you can see the extensive options that are available to tweak it in any way that you need for your particular runs, and all the options that you might be looking for. Once you've done that, we're almost to the end. It'll save it. And then at that point, we'll do another run. And that would be our second run. I think it's going to continue. There we go. So we'll run the same thing again. In this case, I don't use the default option, to try to override that default. It's still just one driver that's going to run. It takes about 43 minutes to run the whole thing all together. Again, about 28 minutes of that is steady state. And then it destroys the data afterwards and spins it all down. In this case, actually, I think the same 3 QoS measures fail because, again, I'm running it on one VM. The same 3 fail again, as well as a different one. Now, that just means that the response time didn't meet what my objective was for the response time. It doesn't mean that the action itself failed. So what you can do, it's very simple to distribute the application. We installed it on that VM, and then the way you would distribute it is you can simply clone the VM where you've installed it. You have to turn off DNS first because you only want that on your run driver, but beyond that, you just clone that application. If you use the naming convention that's in there, and you can see here there's a very simple naming convention. You call them Auction Web 1, Auction Web 2, etc. And then there's the DNS file on the main server, and you change that for the appropriate IP addresses based on the naming convention, and it will pick that all up automatically. So it's not very difficult to distribute it. It is a little tedious, I'll admit, but it's definitely not difficult to do so. It picks it all up automatically and then knows that when you run it, how many web servers you have and where they're located based on that DNS. So it will automatically account for that, and each VM contains all the services, and the Weathervane run harness turns them on and off appropriately. Now, I want to talk a little bit about vRealize automation. I'm a specialist in automation integration, so of course I had to see what happens if I automate this so I don't have to do that tedious work of moving everything all around. And so if you're not familiar, vRealize automation has a self-service portal with policy-based governance on it. Does a variety of services as well as multi-cloud. So you could use it to provision out to AWS native, ultimately VMC and AWS, as well as in your private cloud, and a few other services too. So it has a, we're going to see it in action, but it has a catalog that allows you to provision a number of services, including containers and container hosts. And in fact, the Weathervane run harness will count as a container host, is how it will recognize it, because it is, in a sense. You do your blueprints, and we're going to see that in just a minute. You can do both traditional and hybrid apps. And I think that Weathervane is well poised for benchmarking hybrid type applications in your cloud infrastructures. And then it also allows for the discovery and management of containers. So let's take a quick look at how you can blueprint it in vRealize automation. I had done a little bit of the prep work for you. In this case, I'm going to clone one because I was a bit lazy as I developed this rather than start from scratch. But the essence is the same. As you go in, we have the new blueprint, and what you need to do is we'll change the name. I had already set up a prefix, a machine prefix for auction, so that I know that when it's provisioned that it's related to this. And then I am going to use the Weathervane that I had originally installed, took a snapshot on it, and I use that then to make a link clone for the Weathervane when I use this. You've got, you need to make sure your CPU is appropriate, etc. Once you've done that, I simply need to publish it out into the catalog. We'll do that right here. Make sure it's in the service that I want it in. And then from that point, you can go over to the catalog. Will show up there. And I can say, hey, please deploy me one of these Weathervanes. Now, of course, you can also use it to deploy the distributed load if you wanted to do that as well. You do need a little bit of orchestrator work, though, to configure the DNS server on there because of those configurations. Although you could conceivably do more of a hard-coded template as well if you're using then the private network space where they had the same IP address. Repeated, you could do it that way. So we've gone ahead and done it. I sped it up a little bit. It took about 10 minutes to deploy normally, or 5 minutes, but there it is. And I'll go look up the IP address, and we can go and make a run off this one too. So it has deployed my new VM. I believe it called it Auction 001, if I remember correctly. So there was my original Weathervane, and now I have a new one that is Auction 001. And if we go ahead and SSH in, we can make one more run to see how that looks. So you can see everything is there. This one took about 40 minutes to run. And it was very similar, and it also had, unsurprisingly, very similar quality of service failures as well. And that's how you can very simply bring it up in vRealize automation and blueprint that to do it. So what if you'd like to learn more, right? What else is out there? Well, there are some much more technical deep dives into performance diagnostics and benchmarking. That's available in Hands-on Lab, and they have Weathervane listed in there as well. So if you want to get your own hands on it, you can go and look at that lab. And then there's a breakout session as well that talks about a variety of the tools that are available, including Weathervane and the VMware. So do take those. They're coming up over the next few days. You can also find out more information. There's the VROOM performance blog. I left the links there for you as well. And the primary mode of communication is on a Slack channel, and you can see that there. It's available on GitHub. It is open source, so you can get that at any time. I want to say thank you to Hal Rosenberg. He's actually the developer of Weathervane. It was his pet project. Poured about 5 years of his life on that. He's one of our performance engineers at VMware. And Rebecca Greider actually spoke about this for the first time last year at VMworld, which I saw the presentation on and was very interested and had to dig in further on that. All right, so thank you. And